Hi Alex, how are you today?
I'm doing well. How are you?
I'm very good, thank you.
Excellent. So today we're going to discuss our homework from the last video from section 1.4 when we learned about systematic method design. Now, just as a reminder, we're going through the book called AP Computer Science Done Right. I'll just write that as a comment here. Um, and we're going through each section and each homework problem together. So just as a reminder, could you tell us what we learned on the last video?
Yes, sure. In the previous lesson, we learned how to develop classes and methods systematically. So, we get to know about beta parameters and also about testing and design recipe.
Yes, excellent. And remember that we said the design recipe is potentially the most important thing that we'll learn on in this book and in introductory programming in general. So it's super important. Excellent. All right, I will remove these comments real quick and let's go through the um, questions that we had, the homework problems that we had. So if you recall, the first problem was about a swimming pool that Ehsan wanted to create so that he could consume water through the swimming pool instead of plastic water bottles all the time. Um, and we needed to design the said swimming pool. So from the get-go, we know for sure we need to create a new class because we're going to have to explain something complex that needs to be through a class. So let me just rewrite what the problem is. So the average person consumes about 3 liters of water each day. And he decides that his entire family can probably drink from an Olympic-sized pool, and he assumes a lifetime of 80 years. So after 80, you don't need to drink water anymore, apparently. Um, so we want to represent this pool with its dimension, and we want to have a method that computes its volume. So first of all, what are the important pieces of information that we need to represent as data in the pool class?
So we need to know the length of the pool.
And what type of data is it?
It's a double number.
Okay.
Another double for width and height as well.
Okay. Any important information that we need to add as comments?
We can say that the length is going to be in meters.
Double width. Is the width also going to be in meters?
Yes, I think so.
Okay. And then height.
And height as well.
Also in meters. Okay. What's the next thing that we have to do when we are creating a class?
So we have to create a constructor.
Okay, great. How do we create a constructor?
So we'll start by name pool because we've used it already.
Yes, so we have to start with the class name, and then it's just the parameters that we need to pass in for the field, right?
Right, yes.
Excellent.
But
Unfortunately,
Exactly.
IntelliJ does a lot of these things for us, so we'll just have to this dot height gets height. Okay, so once again, remember this is referring to this, the field. This is referring to the parameter that's being passed. Excellent. Now we want to add a method that computes the volume of this pool. So remember, methods are always inside the class, and they are talking about a specific example, a specific instance of pool, not just general pools overall. So what's the first thing that we do?
Right. We know that we have to multiply the length, width, and height together to get to have the volume of the pool.
I want to pause right here. Irfan, I'd like us to go through the design recipe. So it's great that you already know how to compute this. But if we were to go through the design recipe to systematically design this method, what's the first step in the design recipe?
Is to write a purpose statement as you've written.
Excellent. What's the second step?
The signature.
Excellent. So what's the output that we are expecting?
The output is going to be a double because all the numbers are double.
Perfect. And what's after that? Should it expect anything? Is there any input outside of the pool?
I don't think so.
Excellent. Yeah, so it's going to be an empty parentheses, but we just need to give it a name. I think get volume is a pretty good name. Or actually, instead of get, since it's not a field, we can just say calculate volume. Okay. Now what should we do? What's the third step of the design recipe?
Now we can multiply the numbers.
Ooh, but before that, do you remember the third thing that we have to do in a design recipe?
Oh yes, you're right. It was an example.
Exactly. So let's say, for example, for so let's think of an example. If we have a pool with length, let's say 10 meters, and height of 3 meters, let's say. I mean, a width of 3 meters and height of 2 meters. What should we expect the volume to be?
60 cubic meters.
60 cubic meters, exactly. So it's 10 times 3 times 2, which is 60. Excellent.
Right.
All right. Now, the fourth step of the design recipe, what should we do?
We code.
Yes, exactly. Okay. So our code already has the purpose statement and the signature. So we just need to write the method body. Whatever is inside these braces is called the body. So how should we write the body?
So we want the Java to return us. So we can say return.
Okay.
This dot length multiplies by this dot width and this dot height.
Yes, exactly. Perfect. Very simple method to comprehend, very easy. Are we done?
We have to test.
Exactly. The next step is to test. Now, different IDEs will have different methods. What we will do is called JUnit tests. And the way that you do this is you can right-click and you can do generate, and then you can generate a test. IntelliJ will already create a JUnit testing library, and it will be called pool test because it's going to be testing this class. And we can actually already select we want to create a calculate volume test. We press OK, and then we get this file, which is JUnit. There's some importing issues, so we can click on this red. I'm going to add it to the class path so that it knows. So the first time you create a test, it'll take a little bit of time, but look, easy enough. So now we can actually write a test for calculate volume. So in general, to write tests, you can say something like assert equals. For example, you can say 1 is equal to 1. And then when you run this, it will return true because, yes, 1 is indeed equal to 1. But that's obviously not a useful test, and it's not testing our calculate volume. So let's say, what are we expecting for our pool test? So first, let's actually have an example pool. So we can do pool, whoops. Let's create a new pool. And would you like to give me some dimensions for our pool?
Of course, so length is going to be 5 meters.
Okay.
In 3 meters of width.
Width, okay.
And 3 meters of height as well.
Excellent. All right. So we expect example pool dot calculate volume. What do we expect the volume to be?
45.
Right, so we can actually just do 5 times 3 times 3. Because, it's not a test on our multiplication skills, it's just a test on whether or not this is working correctly. Okay, does this make sense?
Why did you write assert equals first?
Okay, so this is a very good question. So JUnit is a testing library, and it has a bunch of methods already defined. One method that it has is assert equals. Assert means that you can assume, you can guess, you can, you can define or clarify that the two things that I will send to you are equals each other. So JUnit has things like assert true, assert false, assert not equals, assert greater than.
So these are the methods that are already designed in JUnit.
Yes, precisely. So if you want to test x is the same as y, you would use assert equals x and y. If you want to test x is not the same as y, you can use assert not equals, and then you pass in x and y. And if you want to test x is true, you can do assert true x, test x is false, assert false x.
Now I see these are very useful.
Yeah, it's very useful indeed. So we want to test that example pool calculate volume is the same as 5 times 3 times 3. Would you agree?
Right, yes.
Okay, let's see if we can run this. Oh, this is running main, sorry. Instead, we want to run this guy. Let's see if we can run it. Create file. Okay, we have to give it a little bit of time. It's running main, which is about the paper planes from last homework. It's indexing. But we can also, so one thing I will say about this test is that it's a little risky to have two of the numbers be the same for your tests in general, especially if, like, let's say you're going to multiply and divide. It's hard to know, well, did it do it correctly? Did it divide by this and then multiply by this? Or did it multiply by this and divide by this? So
oh, yes.
I'd like to add another example. Bigger pool. Bigger pool. Let's say it's 4 meters, 2 and 1. Actually, 1 is not a good idea because it's 1 doesn't change the multiplication, so we don't know if it's actually working. It's a really weird pool. It's 3 meters deep and then only 2 meters wide, but I'm sure it's fine.
And it's called bigger pool, so it's smaller than example.
That is true. It is smaller. We'll change this to 14. And then we'll just say bigger pool dot calculate volume. What should it be the same as?
Should be the same as 14 multiplied by 2 by 3.
Exactly. All right, this is taking its sweet time to run. So I don't know what's going on here. But we can move on to the next problem and then come back and write these tests after. Okay, so Irfan, we have created the method calculate volume and we're trying to test it. So we just need to change the main method, the main class to be changed to current file. And then you can just run this. And it will take a little bit of time to build initially, but then once it builds, it will tell us if the tests passed or failed. While we wait for that, we know that the next problem set is to have how much left method added to the pool class. Let's see, this is just about to build. Great, so it tells us one test passed, it ran this test, and it was correct. Now, just to show you that it could be wrong, for example, we gave it the bigger pool of 14 times 2 times 3, and that should be the volume. If we change our expectation to 14 times 4 times 3, and we try to run this test, we can see that the test fails. And it says, I expected to get 84, but I actually got 168. So I expected to get 84 from this, but I actually got 168. And we know that's true because we multiplied by 4 instead of 2. Does that make sense?
Right, yeah, it makes sense.
Excellent. One thing to note about Irfan, because they're all in one method, calculate volume test, IntelliJ will tell us that one test failed or one test passed, even though we have 2 assert equals in here. We're actually testing both the example pool and the bigger pool. So just be mindful of that when you run your tests. You're going to get the number of tests as the number of methods that you have in your pool test class, not the number of acidicals. Does that make sense?
Oh, okay. Yeah, it makes sense.
Okay, perfect. All right, so now that we have tests running, let's go ahead and add the other method from our problem set. So we want to have, I'm just going to minimize this so we can write things. So we want to have a how much left, a how much left method that takes in a person's age and then determines how much water should be left. And remember from our assumption from the previous problem set that we're assuming each person lives 80 years.
Exactly.
Excellent. All right, how do we systematically design this method, Irfan?
So we wrote the purpose statement. The next step is to write the signature.
Mm-hmm. How do we write
We expect it to be a double, so we start by writing double.
Mm-hmm.
And then, just a second, it's going to have a name.
Mm-hmm. That's correct.
Calculate how much left.
Yeah, so we can just write how much left as the name. Okay.
And then the parentheses.
Uh-huh.
What do we do next?
So remember, the signature takes in an input and an output. So our output is going to be a number, a double. What's our input in this method?
It's an int number, the person's age, right?
Right, so it's the person's age, but if we have to check if we have access to this from this class. Does this class include a person's age?
No, there's no. So we need to write it down in the parentheses, right?
Exactly. So we need to write it down in the parentheses. And given that the age is going to be in whole numbers, you're not going to get 24.5 unless you are. We can write it as int. And I would say person's age. All right. What's the next step of writing a systematic method?
So after the signature, we will code.
Ooh, you're skipping one important step here, Irfan. So we have purpose statement, we have signature, and then we have
example.
There you go. Fantastic. Yes. So let's write an example. All right. How can we write an example for this?
So another pool.
Mm-hmm.
We have to create a pool.
Let's say we have that pool. Let's say we have the pool already. So we have a pool example. Oops. Okay. And we're calling this method.
We give it the dimensions.
1 second. I think you're confusing a few things here. So this method doesn't care about the pool itself. It cares about how much water should be left for this person. So in our example, we'll start with the signature. We'll start with, well, the input is going to be a person's age. So we're going to start with, let's say we give it a 20-year-old. And if we give it a 20-year-old, that means from 20 till 80, how much water should they have? And remember that we talked about each person should have 3 liters of water every day.
Right, yes.
Okay, so how do we calculate that for a 20-year-old who's going to live until they're 80 years old?
We multiply the age by 365 and then by 3, right?
we don't multiply the age, we multiply how long they have left, right?
And yes, so 80 minus 20.
Yep, exactly. 80 minus 20, so that's 60 years that they have left. We multiply it by 365 because that's how many days there are in a year. So that's how many days they have. And then we multiply it by the 3, which is the 3 liters of water. And then we get a number that is liters of water that is needed for this person. Or
Right.
no, for the given person. Okay, does that example make sense?
Yeah, it all makes sense.
Okay, can we do another example? Could you please give me another example of this method?
Of course. So when another age, like 35,
35, okay.
we will have how much left? 80 minus 35. And then again multiplying by 365, and then 3 again.
Exactly. Okay, and then you get a number again.
Exactly.
I have a question for you. This number, can you tell me anything specific about this number? Will it always be a whole number? Will it always be a double? Will it always be, would it depend? Sometimes it will be a double, sometimes it will be a whole number.
I think it will always be a whole number.
Exactly. Because our age is guaranteed to be a whole number, so this part will always be a whole number, and then we're again multiplying by whole numbers again. So we are guaranteed for a whole number. So we can actually change our signature to a whole number. Wouldn't you agree?
That is right. Yes.
Excellent. Okay. See, this right here, Irfan, is why we have examples. We wouldn't have been able to figure this out through tests or, just writing the code off the bat because, it would still work. The double will still give us the right answer. But because we walked through an example together, we realized, oh, we're actually always just going to get a whole number. So we might as well convey that and just write int instead. Would you agree?
That is right. Yes, exactly.
Excellent. Okay, what's the next step of writing systematic methods?
After signature and example, we code here.
Excellent. All right, how do we start the code?
How do we start to code?
Oh, are you asking me now as well?
I'm asking you, yes.
Okay, well, from our example, the code can kind of just come naturally, right? So the first thing we're doing is we're calculating how long the person has left. So we can just say, 80, which is the life expectancy, minus person's age, right?
Right, exactly.
And then we're going to multiply that by 365, and we'll multiply that by 3. And we know since we're expecting the method to give us something, we need the return statement. So we're just going to return this. Does that make sense?
Yes, totally.
Excellent. All right. You might think you're done here, but to make this code really, really excellent, and again, the thing that makes the difference between great programmers and mediocre programmers is these numbers right now are just like magical numbers. I have no idea why these are here if I'm just reading this code. And if I make a mistake and I somehow think that there are only 364 days, it's hard for me to debug and make sure that there is a correct formula. So instead you want to have these as variables. So you can do something like this. Int life expectancy is going to get 80. Whoops. Days in a year is going to be 365. And liters per day, it's going to get 3. Then we would replace this with our variables here. And then it makes it super easy to understand. Oh, okay, how much left should return the life expectancy minus the person's age. Got it. Multiply it by days in a year, multiply it by liters per day. Super easy to read. Does that make sense?
Now I see. Yes, exactly.
Excellent. All right. Are we done?
Nope, we have another step, which is testing.
Fantastic. Yes. Okay. So we can create a new test. And the test could be called.
Sorry, I have a question. How do we test again? Can you do it again on the screen?
Yes, absolutely. Thank you for asking. So if you don't have a test file and you've never created a test file, you can right click here and you can say generate, and then you can say I want to generate a test.
Okay.
But if you've already created a test file for a class, so our full test already, one thing you can just do easily is just do Command N, or just again right click, generate, and then we want to say, okay, I want to test a method. I want to test a method, and then you give it a name. So I'm going to test how much left. And this annotation here tells Java, hey, this is a test class. Do whatever you need to do for a test class. And then we can continue with these things. So again, I'm going to create an example pool. I'm going to have to create it again in this method. So example pool. And then I'm going to say assert equals example pool dot how much left given a 20-year-old. I expect, what do I expect? I expect 80 minus 20 times 365 times 3, right?
Exactly, yes.
Excellent. So then we run the tests again. Excellent. The tests all pass. One thing to notice here is that it's kind of odd that we have this method in the pool class, because it doesn't really need any of the information of the pool. Like, it doesn't care about what the dimensions are. In any dimension, you need this many liters left. So, you might think, oh, why wouldn't I just have this information on a person class? Because a person will at least have the age, and I can calculate that.
Right.
Yeah, but the thing to notice here is that the information of how much water needs to be left is very much about the pool. People in general, when you think of a person, you don't think, oh, how much water should they drink until they die. That's not really a thing that you would think about a person. But when you think about a pool that's solely existing for providing water for humans to drink, that information makes sense to exist on the pool. So when you think about where to write your methods, you really need to think about what makes sense in the information world as well.
Absolutely, yes.
Excellent. All right, so we have done the problem 1 and 2. So problem 3, if you remember, let's bring it up here. Your friend Zawa has created the following.
Of course, yes. So I think the first mistake here is that the constructor's name is different with the class name.
Yes, that's correct.
So it should be named as watering day. And then next line in the code on the return line. Yes, exactly. That next day should be this that's next day because we are referring to the information that we already have.
Yeah, the IDE would even complain because it doesn't know what next day is. But if you say this dot next day, it will know, oh, you're talking about this field. Correct.
Right, and it doesn't have any comments.
That's right. It doesn't tell me anything about what how much is. Although there is a good comment on the class about how much water to use, but it doesn't tell me, how much water in liters, how much water in milliliters. It doesn't say any of that. And then the alarm is also missing comments. Like, what is this alarm in context of? So yeah, these are exactly the right questions. There's one thing else that's missing. Let me see if you can figure it out.
Let me see again.
Think of it through the design steps. So we went through the purpose statement, so it's missing some comments there. The signatures are there. What else is missing if you go for the design recipe?
There's no testing here.
There are no testing. That's correct, yes. And I think that's the main issue. All right, well, that's all the homeworks for section 1.4. I hope you learned a lot. If there are any questions, let me know. Otherwise, we can finish this section and move on to the next.
Perfect. There's no question. Thank you, Alex.
Thank you, Irfan. Have a good day.
You too. Goodbye.